Okay, hello everyone. Another session. In this one, we cover modules 7 to 9. It's a checkpoint available in reliable networks. We cover module 7, which is DHCP version 4. We have version 6, stateless auto configuration for module 8. Then we have first op redundancy protocol, module 9. I think one of the easiest checkpoints we will probably have. This one is very simple and straightforward. Right. Question one. A DHCP-enabled client is booted. Which two steps will the client PC broadcast messages when communicating with a DHCP server? All right. So to explain this, I think it would be best if we go through the process of DHCP-V4, dynamically assigning an address to a client. So I've sort of summarized this with these steps using Dora, Dora, where we have a couple of messages which basically summarize how a client dynamically gets an address with respect to DHCP version 4. So we have the discover, offer, request, and acknowledgement. The discover, as you can see here with our client, here we have our server. So the discover message is a message sent from the client, which is a broadcast. I think it will be very important to take note of the form of the messages that are being sent at this point, broadcast, unicast, and the reasons why they're being sent as broadcast. So the discover message is a broadcast sent to the servers. Basically, it's a client looking for servers where it can get an IP address from. So that's the discover message. It sends a broadcast so that it gets offers from multiple servers if there are servers available on the network. Then the servers respond with the offer, which is a unicast message sent to the client offering an IPv4 address. So it's basically an offer saying this is the address that we have, and with all the parameters that go with that IPv4 address. We have the request message, which is a broadcast again. Reasons why it is a broadcast, very important. It's a broadcast so that the client responds to the offer. So it can only respond to one offer. However, the message that is being sent is a broadcast. Reason why is to accept an offer, one, and also reject all the other offers that were sent by multiple servers. Because when we're trying to discover a server here, we broadcast. So multiple servers can respond with an offer. So this request message is a broadcast in a sense, or so that we can also get to deny all the other offers that had been offered by other servers. Then the last message with the acknowledgement coming from the server side, which is sent as a unicast directly to the client, basically saying this is an IP address that I've give you, and I'm now tracking and monitoring. I've now registered that this IPv4 address is taken by you. That is basically the acknowledgement. Now, if we go back to our questions, then we'll see. If we go back to our questions, do this. Yes, I can. Right. Going back to our questions, which messages are sent as broadcast? So from the brief explanation of the process, we can see that the discover and the request are the two messages that are sent as broadcast. Right. Question number two. An administrator is just issued in the interface subconfiguration mode the command IP address DHCP. What is the admin trying to achieve? Right, so that command is used when we are trying to configure an interface to act as a DHCP client. So we're configuring the interface so that it can be able to get an IPv4 address from a server. It's not only end devices that are configured to dynamically get addresses. Interfaces can also be configured to do that. And one perfect example is usually when the interface that is connected to your service provider is configured with this command so that it can be able to automatically get an IP address from the service provider. So what the administrator is trying to achieve is configuring the router to act as a DHCP server. No, right. It's basically trying to achieve this, configuring the router to obtain IP parameters from a DHCP server. Not only end devices can get lessons from a server dynamically. Also, interfaces can be configured to act as clients. Right. When a client is question 3, when a client is requesting an initial address list from a server, why is the message sent as a broadcast? I think I've explained this. It is sent as a broadcast, one, as a way of accepting the offer, two, as a way of rejecting other offers from other servers. So let's see which answer speaks to that. The client does not yet know the IP address of the server. No. The DHCP server may be on the different subnet. No. The client does not have a MAC address. No. The client may have received offers from multiple servers, and the broadcast serves to implicitly decline those other offers. If those offers are not declined, there is a chance servers might okay, it doesn't happen, but there is a chance that servers might assume that their offer has been accepted. Therefore, the address is in use, whilst it's actually not in use. So that request message is a broadcast to implicitly deny offers from other servers. A host can only accept one offer and it denies every other offer. Right, which DHCP message contains the following information? That's a broadcast. So that message can either be a discover message or a request. Here we have both messages. That's a broadcast. The client does not have an IP address, does not have a default gateway, it does not have a subnet mask. So this can either be a discover message and a request. But I think we'll probably have to lean with this one, the discover message. Why? Because at least when we request the contents of our message, at least it will have an IP address. We don't have an IP address yet, but the contents of this, we now know the IP address that we've been offered basically. So the offer comes in with the IPv4 address. I'm guessing that's the one we should be here. I'm guessing. I'm not so sure. Question mark with this. If you pass through this, do some basic research because both messages can be sent as requests. That's a fact. However, the contents, is the client already assigned an IP address? Here, it's not assigned an IP address. It's trying to discover. So these addresses with the 00s make sense because the client does not have an IP address yet. However, with the request as well, the address is not yet assigned on the host, meaning the client doesn't have an IP address yet because it's still requesting. So that's why I'm saying question mark. But in an exam, I'll probably lean with this one. I'll do some basic research myself and see what's which answer we can get from number 4. Place the options in the following order. A client initiating, these ones were already put in order. So we have the D, discover, the offer, the request, the acknowledgement in their order, I think. That's not a question, that's an answer. Let's move. Which protocol automates assignment of IP addresses on a network? And which port does it use? The protocol, we know it. Our protocol is DCP, and it uses port number 67. So DCP uses 2 ports actually. It uses port 67 to get to connect to the server. So on the server side, the port is 67, and on the client side, the port is 68. So basically what we are saying, the discover message is sent to port, which one is this one? Okay, LinkedIn. The discover message is sent to port 67, and this one is sent to port 68, this one to port 67, this one to port 68. It's one of those protocols or applications which has 2 port numbers. The other one, obviously, being FTP with 20 and 21. I think there are actually a few more which uses 2 protocols, 2 port numbers. All right, so going back to our question, so here is DHCP and port 67. Port 80, common port numbers, well known. This one is HTTP for web. This should be DNS. Yes, this should be DNS. What is SMB? I'm not so sure about SMB. Basic research on SMB. What's that? Refer to the exhibit. PC1 is configured to obtain a dynamic IP address from the DCP server. PC1 has been shut down for weeks. When it boots, it tries to request an available IP address. Which destination IP address will PC1 place in the IP header? So this is PC1. It has been shut down for weeks. If it's been shut down for weeks, it probably means the lease has expired. So this was its last IPv4 address, that 192.168.1.130. However, since it was dynamically assigned, I think after 2 weeks, that lease would have expired. Since it was shut, it definitely didn't renew. Therefore, the first message which is being sent when it boots up, the destination IP is this one, a broadcast, which is a request or a discover, which is a request or probably a discover, not a request. If the list had expired, then it's definitely a discover message. So that's a broadcast destination, a discover message. These questions can be a bit tricky. Which message does an IPv4 host use to reply when it receives an offer? So DORA, DORA, discover offer, then we have request. Simple, this one. Which command, when issued in the interface config mode of a router, enables the interface to acquire an IPv4 address automatically from an ISP when that link is to the ISP's enables. We've done this one. It's not this one. It's this one. I think there was a question which was exactly the same, a bit vice versa. with this one. So this one is used for relaying IP address helper, and this one is used to create a pool and enter the pool or sub-configuration mode or PDCP pool. So our answer here is B. Question 10. Which kind of message is sent by a DHCP client when its IP address lease has expired? So when a lease has expired, we send a request. We send a request. Okay. When a list has expired, we send a request. Right. Let's go through the process. I wanted to come back here. We said after 2 weeks, the lease is probably expired. What's the difference between an expired lease and not having an IP address? What's the difference between an expired lease and not having an IP address? I hope someone is hearing me. Right. So in case of an address expiring, the process goes like this. So obviously, when a client boots up and it does not have an IP address, the process starts with this one. Here at this point, it means our client now has an offered IP address for a given period, the lease. Now, when we get to, we have what we call timers. When we get to T1, the first timer, which is 50% of the lease. So let's say our lease was 24 hours. Then at exactly 12 hours, the client sends a request, which is a unicast message. So this message is basically alerting the server that the lease is now at 50%. And I'm requesting can we call it an extension to the lease? More time on the lease. So my time is at 50%, I need more time. So the response, you can get an acknowledgement. When it is acknowledged, it means you get more time, more period on your lease. Then if you get a non-acknowledgement, that's a problem. It means you have to elapse the whole lease. Then try to discover another another IP address. Right. If we get this, it will probably lead us to T2, where we are at 87.5% of the lease. So at T2, probably we've got a non-acknowledgement. So at T2, we send another request. But at this point, it's now a broadcast. So the first one was a unicast directed to the server which offered the address. We are requesting a new lease. If we get it, okay. If we don't, we're now sending another one, which is a broadcast. So we are now trying to reach other servers in the network so that we can get our lease renewed. If we get an acknowledgement, everything good. If we don't get an acknowledgement, then it probably means we'll get to 100% of our lease and our lease will expire. When our lease expires, at this point, what's next? We are sending a discover message. We go back to zero. We go back to here. We send a discover message. We try to discover other servers. We try to get an IPv4 address, and the cycle continues like that. Questions? So for this one, which kind of message is sent by DHCP client when its IP address list is expired? It sends a request. Uh, does it send a request or it sends a discover? What does expire mean? Let me see. Who is on the chat? I'm looking at something very interesting, Cheryl and Farai. Do you see something interesting about the word expire here? Get in the chat, James. According to my explanation, when it expires, we say we are now sending a discover. But what does expire mean? Is it at T1, at T2, or after T2? I need someone to get in the chat. Chirungu chinyatsonzwisisa. Expiring yelisi iri papa. Hello? Anyone in the chat? Whilst I'm thinking, I want to go against everything that I know. DCP, what the client does when DCP lease expires. I'm doing a lot of reasoning here. Okay, a client doesn't wait for his lease to fully expire before taking action. Instead, it follows a proactive process. Fully expire. So half expired T2. So actually at 50%, that's when the expiring starts at T1. The client generally doesn't wait for the lease to fully expire. It starts expiring at T1. That's a bit confusing though. That's why probably what I was explaining and the answers I was expecting were a bit different. So it starts expiring at T1. So here it's 50% expired. Yeah. English. I think this will be very much helpful. I'm going to open my exam final. Okay? We should all pass it because of some of these things. So this is 50% expired. This is 87% expired. Then this is 100% expired. So expired, it starts here. So at T1, which message is being sent is the unicast. At T2 is the broadcast. So this is T1 and this is T2. And this is after T1 and T2. We continue to learn every day. Right, 11. The host is attempting to lease an address through DCP. What message is sent by the server to let the client know it is able to use the provided information? What message is sent by the server to let the client know it is able to use the provided information? So this message is coming from the server to the client. That's an acknowledgement. So DORA. This is the offer from the server. The offer contains the IP address, and the acknowledgement is acknowledging the request. So I think our response here is an acknowledgement. This is from client to server. This is from client to server. This is from server to client, but not acknowledging. So not able to use, not able to use. 12. What is one indication that a Windows computer did not receive an address? It will have an APIPA address, this one. So if a host is configured to, not a host, an end device, a Windows host is configured to get an IP address dynamically, and it doesn't connect to the server and doesn't get that address, it will automatically be assigned an address with the prefix 169.254 called an APIPA address. No. These are the loopback. Okay, question 13. Which message will a client send to accept an address that is offered by a server? To accept, we send that's a request, no? That's a request. That's accepting the offer. Simple. It's a broadcast, not a unicast. And we explain the reasons why is a broadcast. A small coffee shop is offering Wi-Fi. The network includes a wireless router, a DSL modem connected to a local phone company. What method is typically used to configure the connection to the phone company? What method is typically used to configure the connection to the phone company? Set a one connection in the wireless router as a DHCP client. This can be an answer. Okay. Set the connection between the wireless router and the DSL as a private network. No, can't have this. Set the DSL model as a DHCP client to get a public address. Set the DSL modem. The modem cannot act as a DHCP client. Set the modem as a DHCP client to the phone company. Modem cannot act as a client. I'll take this one. Set the one connection in the wireless router as a DHCP client. So this is basically allowing, I think this is where we have our IP address, DHCP command coming in, where you allow an interface, which is our one interface in this case, to dynamically get an address from the service provider, which is our local phone company in this case. Question 15. Company uses DHCP to manage address deployment for workstations. The department IT deploys multiple servers in the data center and uses DHCP relay agents to facilitate requests from workstations. Which two UDP ports are used to forward DHCP traffic? I think there's a lot of text there to confuse. They could have just asked which two UDP ports are used to forward DHCP traffic. Obviously, 67, 68, 67 to the server, 68 to the client, from server to the client. Right, question 16. A client device on an Ethernet segment needs an address in order to communicate on the network. A DHCP server with 192.168.1.1 has been configured and enabled on the network. How will a client obtain a usable address for this network? So we have a client on an Ethernet segment which needs an address. We have a server on this address and it's enabled. How will the client obtain? Okay, a client can either obtain the address dynamically or statically. Obviously, here in this case, we're using a DHCP server, so it's dynamic. What happens in the DHCP process? Client sends an acknowledgement. Client cannot send this. Client uses a statically configured IP address from the pool of IP addresses that is offered by the server. No. server offers one address and is not statically configured. C, send a discover message to the physical address FFF. Yes. Broadcast discover. Send a request. That's not the first message you send. So I think C, if we want an IP address, we send a discover to the broadcast. FFF, that's the broadcast MAC address. Advantages of configuring a Cisco router as a relay agent. It can provide relay services. Right, that's our answer. So agents, they not only apply in DHCP, maybe as well. If I can go to what an agent is, let's go back there first. So a relay agent is used in a case like this one. So let's say we have a router, we have a client, we have a server. Right. So let's say we have a network. This is our LAN. This is our switch. Client. This is our server and server 2. Right. So if this client is looking to get an IPv4 address, it goes through the process of DORA. Number one, it tries to discover servers. That message is a broadcast. So let's say we had multiple servers here. This broadcast, the discover broadcast, will get to this server and this server. That's a broadcast. If we don't have a relay agent configured here, it will never get to this server number 2. Reason why routers, they do not forward broadcasts by default. So every time, let's just say broadcast, this is a broadcast domain, by the way. So a broadcast is limited to a broadcast domain. By default, routers do not forward broadcast traffic. So let's now say our server is not on a local network. It's actually, this is the only server that we have, which is on a remote network. Then how will this router be able to forward broadcasts from this client? Because this client will still request for an IPv4 address, but how will the broadcast discover message get here? That's the reason why we configure this as a relay agent. So if you configure it as a relay agent, it allows every message that is coming from this, which is the broadcast, to be forwarded to another remote network, to another server. That said, this function is not only for DHCP, it is used, there are many other broadcasts that are sent from a client making requests. We have NTP, the time protocol. Broadcast messages are sent so that we can connect to NTP servers. They'll need a relay agent so that they can be broadcasted. We also have what else? I'm thinking I could only figure out NTP. Actually, there are quite a lot of UDP services. Thinking FTP, no, it's TFTP. FTP is it's not UDP. TFTP. That's another protocol that makes use of relay agents. Research, basic research. We have quite a number of protocols there. NTP came from the top of the head. We also have TFTP. which makes use of that. Right. Which statement is true about DHCP operation? Number one, A. When a device configured to use DHCP boots, a client broadcasts a discover message to identify any. This is true, né? B. A client must wait for a lease expiration before it sends another request. It doesn't wait, it sends at 50%. So that's false. If the client receives several offers and it sends a unicast, no, it sends a broadcast to implicitly deny other offers. The discover message contains the IP address, subnet mask to be assigned, the IP address of the server. No. The discover message contains no addresses. It's actually asking for addresses, not asking, looking for servers. That's the discover message. Question 19. Order the message types as they would occur between a client and a server. So this is number one. Discover, offer, request, acknowledgement. Simple. 20. A network administrator configures a router to send RA messages with M flag as 0 and O flag as 1. Which statement describes the effect of this configuration when the PC tries to configure its IPv6 address? All right, those flags, they're very simple to understand. So when we are configuring addresses dynamically using IPv6, we can either do that using stateless auto configuration. Okay, but right. We can you not draw a line here? Draw the mouse shapes. Let me try to be clean. Nope. Let me try. All right. It won't work. So we have Slack. We have Slack with stateless DHCP. Then we have stateful. 1 minute. Stateful DHCP. Right. Now the flags that I used, we have M flag, we have O flag, then we have the A flag. And if we're using Slack only, the values here are 0, 0, and the auto configuration flag is high. That's 1. If we are using Slack with stateless DHCP, we have the other, and this one is 1, 1. Then if we are using stateful DHCP, we have 1 here, and the others, they can be whatever they want to be. Now, that's how the flags works. So this is managed, this is other, this is auto config. That's how the flags work. Very simple. Let me see if we can use that to answer the question now. I don't think I'll be able to. My time is up. One more session for the day. Let's close this one.